Okay, so on that paper, again, like I said, we're going to try and go through as much as possible. On the first part of this, before we even get started, I want to make sure we understand something with proofs. With proofs, there are only 5 things that you can use as reasons. So up at the top somewhere, I don't care where you put it, but I want you to write 5 reasons. Now, the only 5 things that you should ever use as a reason when doing a proof is first, a definition. Second, a property. Third, a theorem. Fourth, a postulate. And fifth, a given statement. Now, postulate, again, we said earlier this year, you could also call it an axiom, so that's also fine. They're the same thing. But those are the 5 things that you can use as actual statements as to why you can do something. Now, there are 3 different types of proofs that we're going to talk about: 2-column, paragraph, and flowchart. 2-column is the most important. If you can do a 2-column, then you can do anything else. A 2-column separates your statements, it separates your reasons. The only difference between that and a paragraph proof is it takes it and writes the full line as a sentence. Same thing with a flowchart. A flowchart just shows a logical reasoning, and we'll take a look at a couple of those today as well. So to start off, now we've seen a couple 2-column proofs. This one is actually written as a paragraph proof because it's written in sentences. But the same rules apply. So on this one, they gave us a given statement. It says AC, which is the whole thing, is equal to AB plus AB. So they use this segment twice. And they want us to prove that AB is equal to BC. So first thing they did, they listed a given statement. You are given that, what are we given? AC is equal to AB plus AB. Right? That's what's given to us there. That was the statement that was given to us. AC is equal to AB plus AB. Now, what they write next? Well, by the blank, AB plus A plus BC equals AC. How are we able to make that statement? Well, that's saying that this piece plus this piece equals the whole thing. That was one of our postulates from a while ago. That was, in fact, one of our first postulates we had. Anybody remember what it was called? Yeah. Segment addition postulate. We're adding 2 segments together to equal the whole. This was segment addition postulate. So segment addition postulate. Now I know it's not all going to fit in that little blank there. So you're going to have to make it fit the best you can. But by the segment addition postulate, we're able to say AB plus BC equals AC. Great. Now go down to the next line. All right. Our equation changed. We now have this part, the AB plus AB, and we have this part, the AB plus BC. We no longer have the AC. How are we able to combine those 2 equations? Yeah, that's our transitive property. So that is our transitive property. Transitive property of equality. So when we have 2 equations set equal to the same value, then they must be equal to each other. Again, that's transitive. Finally, then by blank, we can say these 2 are equal. So how did those two equations change? So not substitute, you're right the first time, subtraction. Yeah. So on here, you have the AB is on both sides. They got rid of one of those ABs from both sides through subtraction. So how do we do this? By subtraction. Property of equality. We now say AB is equal to BC. And that was the final statement that we wanted to reach. So again, paragraph proof, no different than a two column. You're doing the exact same things. You're just filling it in a sentence instead of in lines like we were doing on this one. But same exact idea. So now let's go down there to B. Now, this is the one I have issues with. I have a lot of issues with this problem. So they are having us do a couple of things that we haven't quite got to on this one yet. So I'm going to explain it. They also do a poor job of combining things. So I'll give you the steps and then I'll explain why it's not the best. All right. They give us a couple of pieces of information. First, they gave us a diagram. Diagram is very important on this one because we're going to use that diagram. Also, they told us that we're given angle JKL is congruent to angle MKL. Now, if they give me a diagram, I'm going to go ahead and label it with what they gave me. So I have JKL is congruent to MKL. Great. We know those two angles are congruent. We can see what two angles we're talking about. They want us to prove that line JM, so this line, is perpendicular to this line. Symbols are very important. Right? Symbols are very important. So knowing what these symbols mean, again, that means perpendicular. We have the line symbols, we have the angle, we have congruency marks. We have lots of stuff going on here. So the first thing though, always starting off with some type of given statement. So that's where we started this one. We have our angle JKL is congruent to angle MKL. That was given to us. So that's the very first line, given. Now, the next one on there, this is where I have my issue. Oh no, sorry. It's line 3 where I have my issue. I lied. So we have these two are written as congruent. The next line, it says the measures are equal. Well, great. That's something we should know. If angles are congruent, then their measures are equal. That's, no, it's not saying the exact same thing. So here, they changed the idea of they're congruent to their measures are equal. That is a definition. That's our definition of what congruent means. Now, you could write this a couple different ways. You can either write just plain old definition of congruency, because that's what, anytime we have congruent figures, their measures are going to be equal. Or if we want to be more specific, here we're dealing with angles. So we could just say definition of congruent angles. All right, so that's what I'm going to write. Definition, and I do abbreviate. So I usually use DEF when I'm doing a definition. Definition of, I'm even going to abbreviate the other part with my symbols. So definition of congruent angles. Definition of congruent angles. Again, as we do proofs, I will use abbreviations. I will use our symbols. So again, the notation is very important that you understand it. Definition of congruent angles, though. That's what we got there. All right, third line. Now, I don't doubt if you looked at this figure, you could probably come up with a statement. We have our two angles, same two angles that we've been talking about. They said that these two angles together equal 180 degrees, which you could probably reason that out. But in any proof, we're supposed to write why we know something. And that's where this one fails to do a good job, because they actually crammed 3 things into the exact same step. The reason why I say that is, first, we have to recognize what are those two angles. So what do we call those two angles that are next to each other? Because we didn't just magically come up with that they're equal to 180. How do we know, looking at this, that these two angles equal 180? Well, we don't know they're 90. So I put that's an arc there. We know that they're congruent right now. We don't know what the measure is yet. We're going to get to the idea that they're 90. Any ideas? So let me cover up this line. We have two angles next to each other. We had a diagram that looked like that before. Two angles next to each other, they share a common side. They are on the same line. Together they form a line. It starts with an L. No. Linear. They are a linear pair. All right. So I want you to listen and watch what I write first, because like I said, there's a mistake on this one, because there should be 3 lines here for this. There's no reason why they should have crammed this into one step, unless they wanted to use a theorem, which I don't actually see the theorem in the book that they are trying to use. So again, some books cover more theorems than others. So definition of linear pair. Great. The definition of a linear pair tells us that those two angles are a linear pair, but that's all it tells us. We did have something else about linear pairs, though. We had the linear pair postulate. All right, so I'm going to put a slash here. I'm also going to write linear pair postulate. All right, now, what was the linear pair postulate? It said that a linear pair is supplementary. All right, great. What does supplementary mean? Supplementary means our two angles equal what? Look at what we said here. Equals 180. And this is why I don't like this problem. All right. I'm doing it because it was in our book, and why did I just put definition of how to fix that? And white out. White out to the rescue. Hold on. Oh, come on, white out. Whatever. Definition of all right. So I tried using the slides the first time through with my other class, and I wasn't liking it because all this was missing. It was a mess. So we have definition of linear pair tells us, hey, these are a linear pair. Linear pair postulate says, since they are a linear pair, they are supplementary. Finally, since they are supplementary, we know that means that they are equal to 180. Now I said that there is one thing we could have used here that would have just been one line. But have we talked about theorems at all yet? I told you what a theorem was way at the top, right? I said that theorem is one of the reasons we can use. So there is something called linear pair theorem. And that would have taken care of a lot of that all in one step. But we haven't proved it yet. So you can't use it. You can only use a theorem if you proved it. Here we haven't proved it yet. So there's 3 steps there that we need to know in order to get there. And that's where, like I said, sometimes books, they do things kind of out of order, because maybe we should have used the linear pair theorem there, but we can't use it if we haven't learned it yet. So that's why I said there should be 3 steps. All right, well, let's keep going. So now on the next line, the very next line, it says this blank. It looks very similar to the top, but there's something missing. It says we're using substitution. Well, what in the world did we substitute into this blank? So what could I have substituted in for MKL? What's the only other value we know is equal to MKL? JKL. So if I look up at the previous line, MKL is equal to JKL. So we're going to substitute in JKL. Now, at first, that might not make sense because we already had JKL on that line. So now I have measure angle JKL plus measure angle JKL. How does that help me? Well, if you look at the next line, it also shows where we're going with this. What they do, they combine those two values into one. They combine like terms. Now, whether or not you want to say combine like terms, simplify, or substitution property, I'll accept any of those. Now, when you're combining like terms, or when you are simplifying, what you're really doing is substitution. So that's the property we're using. So I'm going to say substitution property here. But again, if you say combine like terms, or if you said simplify, I am fine with either of those. All right, so substitution property of equality. Now, the next one. All right. How do we go from here? It says we're using division property of equality. What are we dividing? What's the only thing we could have divided on this line? Got the 2 out there in front, so we could divide the 180 by 2. That'd be our division property of equality. So measure of angle JKL. What is 180 divided by 2? 90. Again, line 7, I have a little bit of an issue with it because we now said that we have this angle is 90. Great. We can go up there to the diagram. We can mark that as a 90-degree angle. All right. How do we mark a 90-degree angle? All right. Why do we use that symbol? Okay, but what do we call it? When an angle is 90 degrees, it is a, I start with an R. What? A right angle. All right. So JKL is a right angle. That's what the symbol is. It's our right angle symbol. Now, this is the other spot where I have issue with this. They did 2 steps in one again. Again, is there another postulate or theorem that we could use later on? Sure, we haven't got there yet. We got 90 degrees, and they went straight to this fact. So what I'm going to have you do this time, since we got a little extra room here, I'm going to have you cross this out after I have you copy it, because we really need to do one more step. All right. I'm going to put this down a line. Again, this was copied straight from your book, so unfortunately, that's what they had. Oops. That is a great question. We've been told like 3 different times that they are on their way, and they keep changing the date that we're going to get them.
Don't really got like 2 more weeks of this semester.
This quarter. Good thing the first book is for the whole semester, so you know we're going to use it for the first semester.
And then next week, and then the rest of the time.
Yeah. 3 weeks, I think it was 3 weeks. Right?
So
this week, next week, and the following week, I believe. I'll have to double check that, but all right. So why did I have you write that down here? Because there should be one other step here. This angle, we said it's 90. Therefore, it's what type of angle? A right angle. So JKL is right angle. I'm just abbreviating, but JKL is a right angle. That's what we're able to say. If we know the angle's 90, we now know it's a right angle. That's our definition of right angle. Now that we know we have a right angle, now we can say the lines are perpendicular. Because when we look at the definition of perpendicular lines, it doesn't say 2 lines that intersect at a 90-degree angle. It says 2 lines that intersect at a right angle. So definition of perpendicular. All right. Man, my voice really isn't doing so hot. I'm going to try and get through at least the next two. If we don't finish the worksheet today, I'd like to at least finish these next two because this worksheet is actually 2.5 and 2.6 together. So if we can get through the next two, we've at least covered one whole section. Now, on the next one, like I said, a colleague of mine made this sheet from the textbook. They did forget to copy one diagram, and it was for this next one. So we need to draw it in. So I'm going to draw in the diagram here. It was a line with 3 points on it, with the one directly in the middle. All right. So we have T is our midpoint. S is on one end, and U is on the other. All right. And we have two measurements written in. The measurements are actually written as expressions. We have 7x. And we have 3x plus 20. All right. So this is for our next proof. So that was given to us as well. We have our given statement, and we have what we're trying to prove. Well, running through what we're starting with first, we always start with what? The given. So on here, we were given the statement. T is the midpoint of segment SU. So the first line, T is the midpoint of segment SU. Reason, given. Now, look at the steps, all right? We have two steps here. The first step, all right, is going to be definition of midpoint. We know that because it is a midpoint, we have congruent segments. That's what our definition of midpoint tells us. It tells us it bisects it into congruent parts. So what are our two congruent parts? ST is congruent to TU. Then, once we know we have congruent parts, we're able to say that their measures are the same. So we have these two are congruent, so their lengths are equal. Over here, they have definition of congruent. All right. If you want to be more specific, you could have said definition of congruent segments. All right, to be a little more accurate. But there's nothing wrong with just saying definition of congruent, or better yet, definition of congruency. On the next line, take out this statement. Where did that statement come from? What was it? So, are they adding these two together to equal the entire line? Is that what they did in the equation? I heard it over here. What are they doing? No, not combined. I heard somebody say something with an S. Yeah, substitution. Did you say substitution first? Yeah, okay. I thought I heard it over there. So substitution. Here, they replaced both sides of our equation with the values that we had on the image. So replace them with equal values. That was substitution. And substitution, property of equality. Anytime I have property of equality, I usually just put POE. Just to abbreviate, make it shorter. Again, property of equality. All right, next. Line 5, it's telling us we are doing subtraction. Well, what can I subtract on this one? All right, so on both sides, we currently have an X. So we're going to get rid of this 3X over here by subtracting it from the 7X. So what's 7X minus 3X? We now have 4X equals 20. Again, that was subtraction property of equality. We subtracted 3x from both sides. And now, finally, 4x equals 20. How do we get to 5? How do we get to x equals 5 from there? Division. We divided. Yeah. So division, property of equality. All right, let's keep going. So over here on the next one. Oh, sorry. Oh, I moved too fast. All right, we got 5 minutes, so we should be able to finish the next one, and that's where we're going to have to stop. All right. So moving on to the last one that we're going to do for today. All right. All the information they gave us was over here off to the side. Again, they gave us a given statement. So what's the first thing I need to write? That's it. So I'm writing that whole sentence that they gave us. M is the midpoint. I'm going to cut out the word of just so I can fit it there. M is the midpoint of AB. All right, that was our given statement. Now, how do I go from that given statement to saying that these two pieces are congruent? Definition of midpoint, similar to the other one that we just did. So definition of midpoint. Well, if I know that's a definition of midpoint, the next one, saying that the two pieces are equal. Yeah, so here, excuse me, my voice is starting to go a lot. On here, we have those two are going to be equal to each other. That's definition of congruent segments. Finally, there's another open blank here, and it says segment addition postulate. Well, what are we actually adding? That's what you just said. AM plus MB equals AB. So AM plus MB equals AB. Now, guys, we're almost done. Focus. Focus. All right. From 4 to 5, what changed? No, 4 to 5. Substitution, right? They showed it. Substitution. What they substitute? The AM was equal to MB on line 3. So they took that and replaced MB with another AM. So then from 5 to 6, they took those two values and added them together. They combine like terms. Or again, there's 3 different things you could say. Combine like terms, simplify, or the actual property that allows us to do those things is actually what we call substitution. So again, I will accept any of those. So whichever one you want to write, but substitution is the actual property. So that's what I'm going to write. Substitution, property of equality. If you put combine like terms or simplify, that's great. Now, there is one issue here. Hold on. I see people putting it away. I'm putting a line 7 real quick. Why? Look at our proof statement. Does that look exactly the same? No. What's wrong with it? It's flipped. So how do we flip it? What's that property? Not distributive. It was something with an S. No, not substitution. What is it when it looks the same on both sides? I figure is SY M. All right, symmetric. Symmetric property of equality. That's the one that allows us to flip it so that we have the correct final statement. All right, we're going to stop there. We made it just in time. We did all of the proofs that they had in 2.5. The rest of the ones on the sheet are from 2.6. Some of them repeat. They're the exact same thing, but in a flow chart. So we'll get through that tomorrow, and we'll have an assignment after tomorrow's notes. Man, my voice.
That part I didn't get.
How do you, why?
I'm going all white. He said they were all white. He left nothing untouched.